Okay. So we're on now. So I'm gonna share my screen so you guys can see what I'm seeing. All right. So in here. All right. So that's the first question. So let me turn it the other way so that it appears larger. No, same thing. All right, cool. Oh, it actually came up wrong. All right. All right. So most people got this one right. I guess you guys remember it from class. So at least this.
Yes, sir.
Okay, so this one was basically trying to predict what the next year's sales is going to be, right? The sales, right? It says the table shows the income a company receives from sales between 1995 and 2000. All right, so these are important things. Realize that we're working in thousands of dollars. All right, so this is 50,000, 60,000, 65,000, 34,000, 32,000, 50,000. All right, and then these are the years. What it is that they want to know what the sale was in 2001. So basically, we have to predict from all of this data. All right. So the concept is that you want to know what the next change is going to be. You want to know what the next change is going to be to determine what the next figure is. And what that means that these values are all changing. They're all changing. And what we are saying is that our next change is going to be the average of all these changes. Average of all those changes. So our next change is going to be the average of all the previous changes. And that's the concept of it. All right. So
5 changes.
So there are 5 changes here. So I mean, what we always do in class is do the individual changes. And the reason why we do the individual changes is if the question asks us for what was the greatest increase or what was the greatest decrease, right? So that's why I always do the individual change. So for example, this would be a plus 10, and from here to here would be plus 4, then from here to here would be minus 30, from here to here would be minus 2, and then from here to here will be what, 28?
Yes, sir.
28 yes, plus 28. So the question asks you, for example, what was the between which period was the greatest decrease? Greatest decrease would have been right here, right? Here would be right in 1997 to 1998. I ask you what was the largest increase? This would be the largest increase. 1995. No, sorry, wrong.
Yeah,
The last one. Good.
Yes, sir.
This one will be the largest increase. Right? So sometimes I ask questions like that. Yeah. Right? But what we are interested in doing is a change. So what we can do to know what the next change is, so we can know what 2000 figure is going to be, is to work out the average of all these changes. Actually average them. So the average is 5 changes, right? 1, 2, 3, 4, 5. There are 5 changes. And so you will basically add them up and divide by 5. So it will be the average change would be equal to 10 plus 4 minus 30 minus 2 plus 28. And they divide that now by 1, 2, 3, 4, 5 changes. So they're dividing that by 5. Right? And what this works out to is a net change of 10 divided by 5, and so divided by 5, and so the change is equal to 2. So that is the average change. Average change is 2. But you really don't have to do all of this, you know. You really don't have to do all of that, you know, to get the overall change. All you need really is to look at what the overall change is. So the overall change, let me use a different color. And the reason I do it step by step in class, as I said, because sometimes they ask you for information in between, right? But if you look at the overall change from here to here, it's actually 10. From 50 to 60, it's an overall change of 10. And what it is that if you're making 5 changes and you want the overall change to be 10, it means that you have to make incremental changes of 2. But understand that? So you're making 5 changes, 1 change, 2 changes, 3 changes, 4 changes, 5 changes. So the overall change is 10, right? And you want all of them to have the same change, and there were 5 changes. It means that each change is 2. So the average change is 2. And therefore, the figure in the next year is going to be 60 plus 2. The next change is going to add 2 to the 60. So you're going to add 2 to the 60, the average change, which we worked out as 2. So as I'm saying, we could have worked out the average change instead of doing all of this calculation down here, right? Could have done the average change, which is just 60 divided minus 50. That is the overall change, and there were 5 changes. And so the average change is still 2, all right, which is a plus 2. And so you're adding 2 now to the figure for 90 for 2000, and that tells you that the 2001 figure will be 62. And you know that the figures are in thousands, and so the next figure is actually 62,000. So this is the answer. Right, and this was the best answered question of the lot. So the answer is C, 62. All right. So I think almost everybody got that one right. I think most persons. I sent to the statistics. So let's look at the troublesome ones now. All right. So troublesome ones. I'm gonna go back. Save these changes.
Almost everybody get number 4.
Yeah, almost. In fact, almost everybody get the next 3 wrong. Yeah, for real.
You forget of work all them. So.
Those are not normal questions. I set them up, but if you notice, I sent you the question that they came from. So these came from actual paper 2 questions. And these will be like a part of the question, like a part 3 or a part 4. All right, so let's look at the second one.
I'm saying we work them out in class and them look so familiar.
But they are familiar. That's why you have to pay attention to details.
Extremely familiar.
You have to pay attention to details, and that's why I always tell you go home and work over the questions again.
Yeah.
You understand? But I'll tell you, don't do it. You don't go home and work them over again. All right, so this question, we actually did this question in class. Right, the whole question. Right? And this thing down here where they ask us here was a part of the question we did it in class. But you see, things when you do it in the class and you do the part A and the part B and the part C, then you can basically see your way to getting this answer. That's the difference with the multiple choice question. They don't build up the steps for you. Because usually when you do a question in paper 2, right? The first part help you with part 1 help you with part 2, and then part 2 help you with part 3, and part 3 help you with part 4. When they give you a question, then we drop the final thing that they want on you right here. That is where the problem is. And that's where your knowledge comes in. You know, the minute details and knowledge. Because a lot of the times when they write the question, they write it in a way that sort of helps you. They help you towards a solution. And sometimes they give you some information and then they say something like, hence do this or hence do that. So you know that you must use information that you just worked out to get the answer. And so the questions usually on the paper to guide you. And that's a challenge with the multiple choice. You can't take the multiple choice question for granted. You have to know the details to do the multiple choice questions properly a lot of the times. But anyway, so this question gave us the graph. And we have to always remember, read the scale of the graph before you start doing anything. All right. So it's a distance time graph. So the graph above records the journey of 2 riders, Bob and Andy, traveling between 2 stations. So because they said they're traveling between 2 stations, clearly Andy is going from a distance of 0. So Andy starts at one point. Remember, the distance time graph shows distance from 1 point. It can only show distance from 1 point. And so Andy starts at a point where the distance is 0. And Bob starts at this point. I'm going to say this is 44. Maybe if we zoom in closer, it might look like 45, but I'm going to just work with 44, right? So it means that the 2 places are 44 apart from each other. 44, and it's kilometers, 44 kilometers. The 2 places are. So you want to establish that, all right? Another thing you want to look is the scale of the graph. right? So if you look at the scale of the graph, there are 5 lines between 10, and so each line is 2. All right, so each small line is 2. So basically then this is 2 kilometers, 4 kilometers, 6, 8, 10, 12, 14, 16, 18, 20, right? So each line is 2 on the vertical axis, and the horizontal axis, each line is 2 minutes. Horizontal axis, now you're working in minutes. All right, and each line is 2 because there are 5 lines between 0 and 10. So it's similar to the y-axis, similar kind of scale. And we're working in minutes down here. All right. So what did they say now? So this is the journey of Bob. Bob is coming from up here and he's coming this way. All right. So this represents the journey for Bob, and this is where they met. So basically, this is where they met. So this is the meeting point right here. All right. That's where they met. And the question says, how fast, what average speed would Andy need to travel after they met? So they're talking about after this point, so onward. What speed would he have to travel onward, right, in order to complete the journey in the same time as Bob? Now, if you realize on the graph, what does that mean? Is that Bob finished the journey before Andy, right? Bob finished the journey at 72, but Andy finished journey at 80, assuming that actually is going right to the 44 kilometers mark right there, right? Yes, so sir. He reached at 80. All right. So what that means that when they met here, if they're gonna reach at the same time, right? Andy is going at a constant speed, right through, because a straight line all the way. Is going at an average constant speed. And the reason why they use the word average in question like this is because it's over a long distance. 44 kilometers is a very long distance, you know, so you don't expect that the man is going to be riding the bicycle at the exact same speed for 44 kilometers. The speed is going to vary. But what they do, they just over a long period, they use the average speed, the total distance over the total time. And that's the only reason why they put in the average right there. Right? But it's not that the speed is actually constant all the time, right? And so this is saying it's going at this is a straight line, so it's basically going at a constant average speed, right? All right, so that's what Andy is doing. So when they got to this point here now, right? When they got to this point where they met, right? Andy will have to speed up in order to finish in the same time that Bob did. Bob finished the journey at 72. All right. I also want to know the distance that he has left to travel. So let's look at the graph now and pick some information from the graph. All right. All right. So basically, we're talking about the journey from where they met, which is here, and he wants to complete the journey. In other words, he wants to reach the 44. I'm gonna mark it on here now. Use a different color. Right. He wants to reach the 44, which is this. This is the 44 right there that I'm marking, and he wants to reach it in the same time as that. Everybody see that? Right? So basically, he wants to reach here at the same time. So his journey will have to change. His journey will basically now. Hold on. Give me a second. Ignore that. Computer doing this thing, doing what it wants to do sometimes. Let's minimize this. All right. So his journey will have to basically go like this now. He have to change his journey and speed up and go at a faster speed. That will have to be his journey, which is going to complete the journey at the same time. All right, let me put the red mark to represent the time. This will be the time when he reached. Once he finishes same time as this, and he wants to complete his journey, which is to go 44 kilometers. And so he will have to go on this blue line, which represents his speed. This will be now his speed. Now remember now, on a distance time graph, speed is gradient, or speed is distance over time. So what you want to know is work out what is the distance from this point to this point, and what is the time from this point to this point, right? You want the average speed. And you can do it two ways. You can use distance that he has to travel over the time that he has to take, or you can just use and put it over here, or we can just use, because a distance time graph, average speed will be the gradient of a straight line between the 2 points equals gradient. On a distance time graph, speed is gradient. All right. And remember now, gradient is still just rise over run. All right. So what you'll find is that the distance is actually here. When he's right here, the distance is 18. Right here, the distance is 18. And when you reach up here, so the distance is 44. So the distance he has to cover is 44 minus 18. Everybody can see that?
Yes, sir.
The distance is 44 minus 18. Remember, we're working in kilometers, you know. That is kilometers. Because the question did say must convert to meters per second, right? And the time that he will take is now the time from 32 minutes all the way over to 70 minutes. That is the time that he will take. Everybody see that?
Yes, sir.
Comes right from 32, because this is 32, and he's going over to 70. So the time that he will take, this is 70. The time that he will take is 70 minus 32, and this now is in minutes. All right. And so this calculation would basically be what somebody can work it out from
72.
26.
70 or 72, sir.
72. Sorry, my bad. 72. Yeah, 72. Right. So that makes it easier. 72.
Answer 40, sir.
Right. 72. I mean the time of 40 minutes. So that's 26 kilometers over 40 minutes, right?
Yes,
Remember,
sir.
the 26 is kilometers, you know. So to get the kilometers, because you want to answer in meters per second. Where is it? It said in meters per second.
So you have to convert it.
So you're going to convert the kilometers to meters by multiplying by 1,000, don't it?
Yes, sir.
36.
So that becomes meters now. And the 40 is minutes. And we're going to multiply the 40 by 60 so that it is now in seconds. You understand that?
Yes, sir.
All you have to do now is just work this out. And you have the answer in meters per second. So you get the distance that he has to travel over the time that he has to take to go from this point to that point. Right? From where they pass, and they basically want to complete the journey at the same time. So basically then the calculation is 26,000 divided by the 40 and also divided by the 60. And it comes out to be 10.8. 10.833 meters per second. All right, that's it. But that's one way. As I'm saying, we could have also used the gradient. Right? So let's say we're using the gradient at the top here. Could have also just used the gradient, which is just the rise over the run. Right? So could have used the R method, is to say average speed. Speed on a distance time graph is gradient. If you have a distance time graph and you want speed, you can do it by calculating a gradient. And gradient, as we say, is rise over run, right?
Yes, sir.
Rise over run. So what will happen is that you see that you get the same thing. So let's look at the rise and the run. Let me use a different color to look at the rise over the run. All right. So let's use a purple. So we're using the rise over run from this point to this point. So the rise would be a rise of that is still the same 26 over the run to here, which is still 40. See that? So the rise will be 26 kilometers, and the run would be 40 minutes. So if you use gradient, you're still basically doing the same thing. Right? You're still doing the same thing. Use gradient, which is rise over run. So this will be 40 minutes is a run. So you would put 26 kilometers over 40 minutes, and you convert the kilometers to meters. So it's 26,000 meters, and you convert the 40 minutes to seconds by multiplying by 60, and you get 2,400 seconds. You get the same answer, 10.833 meters. You can write this. You can write the per second like this to the minus 1. You can write it like that as well. All right. Now understand that?
Yes, sir. Yes, sir.
All right. Good. So that was that question. All right. So we could go to the next one now. All right. So I have to go back here and pick it off from here. Oh, I have to go back. All right. Let's see. Let's go back here. Oh Lord. Going all over the place. Never bear with me. I'm young to these things. Yeah. Try again. I'll keep back this. I just want to go back. You know what to do now? Come on, tight. Let's start over. My files. See if I can go back to this.
So try save it first, sir.
Alright. I want to see the marking. Well, no, that's still. Oh, why
Yeah.
are Gina no? Why you good?
No, sir.
All right, 3 and 4 on this one.
Yes.
3 and 4 on this one, eh? 2 questions in one. All right. So let's look at this one now. And the first thing you have to realize that this is measurement data. It says in an experiment, in an agricultural experiment, the gaining mass of 103 horses during a certain period were recorded as shown in table. Now, see this question? I got this question, a CXC passport question that said 100 cows. That's all I changed. It was 100 cows instead of 103 horses. The exam CXC question said 100 cows. And then now, instead of giving these now from the CXC question that I basically adapt this question, this right here is a midpoint value. So what they actually gave in the CXC question was a range of values. But these are the midpoint values that I put down here. So I convert from a group data to ungroup data. That's all that I did with the question. Convert from group data to ungroup data, but it's still measurement data. Right? Still measurement data. And when it is measurement data, right? When it is measurement data, you have to remember the range of the values that can be, for example, equal to 7. 7 can be, let's find a point. 7 is a value greater than or equal to 6.5 less than 7.5. Good? But I can see that?
Yes, sir.
Let me make it a little bigger so I can write. Right. So 7. 7 is a value greater than or equal to 6.5 less than 7.5. So any value that is within this range that I'm writing, is going to be used for the mass of this cow. They're going to write 7 on the paper. Understand? Because it is measurement data. Once it is measurement data, they have to correct the measurement to some value, to some figure. It's measurement, you know. When you measure something, the answer that you put down just depends on the level of accuracy that you want to show. You can put it down to 1 decimal place, 2 decimal place, or to the nearest whole number, 3 decimal. You can extend the accuracy of your measurement as far as you want. But once it is measurement data, it means that 7. It means that any cow measure 6.5 or less than 7.5, they will write it down as 7. But understand that?
Yes, sir.
Similarly, this one will start at, this one now will start. Let's have this, so 12. All right, so this one will start now at what? You see, they're going up by 5, you know. So this one can start at 11.5. And come down to what?
12.5, sir.
12.5. And then you go down the line. This one start from 16.5 up to 17.5. Now note me I put the less than on the side here, right? I can include the point. All right, good. So what really happened now is that actually this can take values up to 32.5. 32.5. And so the last value can take values up to 32.5. Right? So the measurement of the cows overall, right? The measurement of the cows overall is therefore from this value all the way up to
that value.
And so that's how you get your range.
Okay.
And I told you, range from measurement data, grouped or ungrouped, is the largest upper boundary minus the smallest lower boundary. Because the 7 starts at 6.5 and the 32 ends at 32.5. So that is the range of the measurement of the cows. Because if a cow measures 6.5, they're going to put it down as 7, don't it?
Yes,
and if a cow measure less than 32.5, if I'm 32.4999999, they're going to put it as 32. So basically, then the range of the measurement is from the largest upper boundary minus the smallest. The largest upper boundary minus the smallest lower boundary. So that is the range, right? So the range is largest
upper boundary.
Now remember these things, you know.
Yeah, man, sir.
Largest upper boundary.
Subtract.
Minus smallest lower boundary. I understand why it is the smallest lower boundary and the largest upper boundary.
Yes, sir.
The smallest lower boundary is where the 7 starts, and the largest upper boundary is where the 32 ends. Right? Cows in this data can start at 6.5 and end at less than 32.5. So that's why that is the range. So it becomes 32.5 minus 6.5. Not 32 minus 6. So the answer for that becomes what? 26. 26 kilograms is the range of the mass of the cows. 26 kilograms. So the answer is B. Good. Answer is B. All right, so I'm going to move up to the next part now. All right. So this part now says what is the interquartile range. All right. We all know that interquartile range is upper quartile minus lower quartile. We're tasked with the objective. We're tasked now with trying to find what the upper quartile is and what the lower quartile is. All right. Now, remember now, the quartiles are position values basically. All right. There are 103 cows in this data. All right. And these are the measurements. And so if you start up, you basically saying, all right, you put in the data in ascending order. The data already is in ascending order. So what will happen is that you want to know where the upper quartile corresponds generally to 3/4 of the data. All right. Generally speaking, it corresponds to 3/4 of the data. So the position of the Q3 is generally speaking 3/4 of n, right? But when
Yes.
you usually use 3/4 of n when the data is ungrouped. Well, when the data is grouped, it's 3/4 of n. Right? So if you work with 3/4 of n, or you work with 3/4 of n plus 1, which is the accurate calculation for the quartiles. 3/4 of n plus 1. You basically go and get around the same answer. Remember, these usually are estimation. Measurement data is usually estimation data, and group data is usually estimation data. All right, so you want the 3/4 of n. Remember, the n is 103. All right, so that's just the position of Q3, not Q3 itself, So I'm going to use the 3/4 n plus 1. Because the n is usually when the data is grouped. Use the n plus 1 when the data is ungrouped. We did that in class.
Yes,
all right,
sir.
so I'm going to use the n plus 1. All right, so let's use n plus 1. But I'm telling you, if you use 3/4 n, you get the same answer. What we can do is use the 3/4 n afterwards and show you what would happen. You more or less get the same answer because, as I say, it's estimation data. So you want to get almost the same thing. So 3/4 n plus 1 term. That's the position of the term. That's not the term, that's only the position of the term. So you're basically calculating 3/4 of 104. Because remember that n is equal to 103 from this 103 course, right? So n equals
Yes.
103. So 3/4 of the n plus 1, which is the position of the upper quartile. Right? Position of the upper quartile. 3/4 becomes equal. Somebody wrote that out for me.
28.
That becomes 78th. So that is 78th horse, or the 78th term.
Yes, sir.
78th horse, or the 78th term. So the 78th horse would have the Q1 mass. All right. So that's what that is equal to. All right. And then we're doing the position now of
the first quarter.
Q1. So this is only telling us where it is, We don't know what it is yet, So after we find where it is, we have to go and find it. We're doing a cumulative frequency graph. We'll go up on the y-axis and find the 75th cow, if it's 100, and come across and read the measurement, right? This is not a cumulative frequency graph, so we're going to have to get it from the table. So watch this now. So the position of the lower quartile now is 1/4 of the n plus 1th term. This is the horse, right? You're trying to find which horse of that mass gain in mass. All right, and so it becomes 1/4 of 104, which becomes what? What is that?
Supposed to be what, 26?
That is 26.
Mm.
Right, so that's the 26th term, or the 26th horse. All right, 26th term. All right, so those are the quartiles. All right, and so is how you find it now. All right, so these are the horses, and the data is look back at the table now. The data is in ascending order. All right, let me use the blue ink. Right, the data is in ascending order. So basically, you want to count up the cows until you reach the 75th cow. I want to count up the cows until you reach the 25th cow. So you put in the first 3 cows, so you're basically doing a cumulative frequency, That's what you're really doing. You're counting how many cows you have as you go up the table. All right, that's what you're basically doing. So when you finish putting in the cows, you measure 7. Right? You put in 3 cows. So you got 3 cows. and then you put in 23 more cows. So when you put in 23 more cows, so you have 26 cows now. What is that?
Yes, sir.
Put in 16 more cows. Much you have now after you put in 16 more cows? 26 and 16.
39.
No man, 26 and 16. 16 you add now. You put in 16 more cows in the line. The cows are measure 17. You put them in the line now. So much you reach? 26 plus 16. 42?
Yeah.
Yes, sir.
42 cows. And you put in the other cows that measure 22 kilograms. You keep putting them in the line heavier and heavier and heavier as you go. You're putting them in from the ones who weigh the lowest mass to the one who measure the highest mass. All right. Remember, to find the quarters, your data have to be in ascending order. All right.
Yes,
Data
sir.
has to be in ascending order. So after I put in 14 more, how much you reach? 56, right?
Yeah.
And after I put in the 56, then I put in the 21. This can write so good. Let me erase it and write it over. Write it over. Kind of looks so good. Right, let me erase it. Write it better. Everything important. Alright. So we're doing the cumulative frequency. I was trying to count up the cows. How many cows in the line as we get to the various weight and the various mass. So first you have 3 cows in the line. They'll put in the next set of cows to reach 26. And they'll put in the next set of cows. Next set of cows reach 26. Then put in the next set of cows to reach what? 42, we say? 42 cows. After we put in the 17. And after that we put in the next 14 cows, we reach 56. After we put in the 56, now we reach how much? 77. And you put in all the rest of 26 cows, you reach 103 cows. Alright? So remember now, you are trying to find the 26th cow. 26th cow. So you actually reach the 26th cow right here. So this now is the position. That's the position. It's the position of Q1. And so Q1 is at 12. See it? Q1 is at 12. The 26th cow measure 12 because the 26 cow in another group here.
Oh, yeah.
Yeah.
So therefore, Q1 is 12 kilograms. The 26 cow measure 12 kilograms. And you go down the line, you have to go, you try to find the 78th cow now. So you say you reach 77 cows. You don't reach the 78th cow yet. So the 78th cow was in the last group here. The 78th, that group has started with the 78th cow. So this is where the 78th cow is positioned. This is the position of Q3. Therefore, Q3 is at 32. Measure 32. Understand?
Yes, sir.
Yeah.
Right? So remember, you know, the first 3 cows measure 7. The next 23 cows measure 12. The next 16 cows measure 17. The next 14 cows measure 22. The next 21 cows measure 27. And then the last 26 cows measure 32 kilograms. So you finish 77 cows, yes, sir. So the 78 cow must be one of them last 26 cows here. See that?
Yes, sir.
Right? And the
Yes,
mass
sir.
of that cow, the mass of that cow, the 78th cow,
It's 32.
Q3 mass is 32 kilograms. Yeah? And so we can come back down here based on that now. And so therefore, our interquartile range
You'd have to subtract.
is 32 minus 12, which therefore is 20 kilograms. 20 kilograms. You understand?
20.
Yes, sir.
So now remember these things, and when we get questions, we're going to challenge like this. And have to remember them. And have to remember them. And that's for the answer. The answer therefore is A. Answer is A. All the two persons put A. I don't even know if them calculated the right way, but that's the right way to calculate it.
Me get A, no, sir.
Huh?
Me
Yeah,
get
the
A.
way I got A is completely different. Oh, God.
All right. All right.
See there?
All the good things that are multiple choice. Then don't need to see how you get to the right answer.
Yes, sir.
Remember, let me tell you something. Remember about multiple choice question. The correct answer is on the paper, boss. You don't know sense the correct paper on the paper right there in front of you and you write the wrong thing, you know. That's a travesty of justice. The correct answer is right there and you choose to write the wrong one. And the correct answer is there. Out of 4 answers, the correct one is there. And so many persons just choose the wrong one.
That's
right?
Earth.
Anyway, when I get better still, all of this is improvement. And I did that with those questions because I sensed that person was sort of feeling like they want to get complacent because the year is multiple choice of doing. I don't want that to happen.
Yes, sir. The plan to just go in there and
Give you
just
some right. I gave you some
Most
questions to show you that
2 egg
multiple
question.
choice questions can be challenging and can be tricky. You can't take it for granted.
can't take them for granted.
Can't take them for granted. Let me ask you one more thing with this data.
More.
Right. So when I'm asking for the median, the question asks for the median.
The most common one.
They add the twos, they add 17 and 22 and divide it by 2.
Nope.
That's a
The median is a quartile as well. The median is Q.
The second
quartile.
2. You have to do
median is Q2.
You have to do the position of
median
the
is
second
Q2.
quarter.
So the
And
median is half of the n plus
n
1.
plus 1.
So the position of the median, it not equal that. Let me not write that. Median is Q2. Let me not write the wrong thing. Everything important. So the median is Q2. So the position of Q2 equals half of the n plus 1 term. See that?
Yes,
so
sir.
basically, right, so put up here. Median equals Q2. And this is the position of the median. This is just a position of the median. So that would be half of the 104, which would be the what?
52nd term.
52nd term or the 52nd horse, right?
Yes, sir.
And then where would be the 52nd horse? In this group.
Round thing there, sir.
Right here, sir.
Yes, sir. Right there, sir.
So you reach here, so you reach 42 cows, right?
Yes, sir.
Let's go all the way up to 56. Somebody need to mute the thing. Mute the thing. All right, so this will be the position of Q2. This is where it will be the position of
Q2.
And so Q2 is a cow weight 22.
Yes, sir. With a median, right, sir?
That's the median. So the median will be 22 kilograms. So therefore, Q2, the median is 22 kilograms.
It makes sense,
right?
sir.
Yeah, so no need to just work over the question by yourself. Remember, in the question and the problems, you need to work it over by yourself. You can't be lazy with these things. See if there's anything else I want to know.
What did you say?
I'm trying to see if there's anything else I want to tell you. There's always something else to tell you, That's how maths is,
Sir,
there are many other things I could have asked on the question, right?
Yeah, they ask about the mode and then thing there.
Well, the mode is the one with the highest frequency, right?
Yeah, which would be 12. No, the 32.
No, the
32 would be the mode.
Yeah.
Right? If you want to do the mean, this one easy because it's on group data. You would do your sum of fx divided by n, right? Remember, so this is really the frequency, So you multiply the frequency and the mass, right? You get that will basically represent the total mass of all the horses, and you divide by the number of horses, which is 103, and that will give you a mean. This will be the mean. This is what will give you the mean. This will be the mean. So we calculate the mean. This is the F and this is the X. Alright, so you do the sum of Fx to get the mean. So it's mean, mode, median, range, interquartile range, semi-interquartile range. Those are the statistical averages and measures of spread. So basically, I spoke about all of them right here. Talk about the mode, talk about the mean, talk about the median, talk about the interquartile range. So the semi-interquartile range will just be half of the interquartile range. So let me ask for the semi-interquartile range. Let's put it down here. Semi-interquartile range, if let me ask for that, would be equal to the interquartile range divided by 2, which will be 10. No, not 20, it was 20, right?
Yes, sir.
It was 20. Sound like I'm not tired now, man. It will be 20 kilograms divided by 2, which is 10 kilograms. Alright, so basically that's it. You could have some probability as well, like what's the probability that a cow measure 27 or more, something like that. If the master something like that, you'll be talking about these. And so this will be the number. Add up those, that will be 47 divided by 103. Understand?
Oh.
Let me write it up here. Use a different color and write it. Let me erase these. Alright. And then we're going to stop right this second. Sound like we're not dead.
Thank you, sir.
You're not good like me, you know. You're soft. You guys are soft, man. Soft. Right, so these are the cows. These are the cows that measure 27 or more. Here. Right, and this is the number of them. So the marks are probability question. Let me put it right here so now in a box. Right, so the marks is something like probability of the mass. I use X to represent the mass. Greater than or equal to 27 kilograms. Then the question I'll be talking about the ones in green. That total number will be 21 plus 26, which is 47, divided by, let me write it. Sure, I want to get it. Right, put and show you how you get it. Right, so it will be 26, 21 plus 26, 21 plus 26 divided by the total number of horses is 103. Whatever that work out to know will be the answer, which will be 47 over 103. Right, so sometimes I like to ask some like a probability questions like that.
0.456, 0.446.
Yeah, sometimes you can leave it as a fraction because something out of something, you understand? So you can leave
Yes, sir. Probably. You know, they don't really want a decimal.
yeah, most time they don't want decimals. And they ask for probability because you want to express it as this number of things out of that number of things.
For real.
Understand? All right, gentlemen, this is it. So I encourage you to work these questions over again. The plan for tomorrow is to send a paper for you, and you do it. I might actually work it out on Sunday. So I might not work out that paper tomorrow. I might work it out on Sunday. All right.
Yes,
So
sir.
just keep practicing. So don't make them tell you about multiple choice and you drop your guard. All right. Keep up the hard work. Pay attention to all the minute details. Everything important. All right. So basically that's it. So I can hand over this thing now. All right. So I'm gonna end it now. Cool.
Yes, sir.
All right then. So we'll talk. So when the person joins, only two of you still?
No, sir. It was
Oh, a good number of person came on. Nice
David
man.
Foster.
What, Chad? Chad. I saw some persons came on and left. So I go still. I'm going to save, I'm going to send the recording anyway to the group. So people get a chance to watch it. So it's not a problem. All right then.
Yes, sir.
All right, cool. So tomorrow.
Yes.
Well,
All right, bye.